Hi, this video is going to be the walkthrough example of how to do the linear regression part one Excel assignment. So I'm going to use the car prices worksheet that we were working with in class for my example. So the first thing I see is that I need to copy it into a new Excel file. So I'm going to right click down here on the tab and I'm going to go to move or copy, create a copy, and I'm going to go to the drop down and pick new book. And I'm going to put that copy here. And now that I'm here, this is where I'll add when you do it, when you do yours, you'll be adding a worksheet, each of the worksheets out of the chapter 7 data in here. And I'm going to save this as, and hopefully by now you've got this all straight. You have auto save off. You have the save as an option. You can choose where you put it. I'm going to put it in our class data, and I'll put it as I told you to call it by your last name, regression analysis part 1. Okay. So I had saved it already when I thought I was recording and I wasn't. Yay. So I have to do it again. Okay. So the next thing is run the correlations between all the variables with each other and with the response variable. So that is what I did in class, and we saw that here. So in the class video for today's, I kind of remind you, and I also did it back in chapter 3, and hopefully you practiced it before the exam last week. Okay. The next thing is determine which variables have correlations with the response variable with an absolute value greater than 0.15. These are your candidate predictors. Okay, so candidate predictors. And I'm just going to copy the candidate predictors right here. All right, so those are my two candidate predictors. I have to run correlations, graph scatter plots of the candidate predictors with the response variable. So this up here was more for talking about correlations. I'm going to, for the purposes of this assignment, I only need to look at each of the predictors versus the response. So mileage versus price and age versus price. I will come back later in the second assignment and look at how age and mileage are related, because if they are tightly related, we have something called collinearity, which can mess up modeling. And we have to take that into account, but that is like information that I will be giving you after Thanksgiving. So for right now, I just want you to get started doing these. All right, so the next thing we want to do is we confirm there's a linear trend. Yes, we did. Perform the initial full model regression analysis. So this is what we're going to call the full model. And the full model is when we include all the predictors that we identify as the candidate predictors here, and they get initially included. So I'm going to go to data analysis, regression. And in this regression, I'm going to have my input Y range, and notice it is the price, which is still there. So that's great. Now what's going to change is my input X range. I am now going to put in a rectangle of data, and I'm going to have my predictors names in the first row, and then I'm going to select the data. I'm going to tell Excel I do have labels in those first row, and the confidence level, I didn't really get a chance to go over it in the video very much, but that's okay. We'll talk about it later. I don't even care about that, it doesn't matter. We're ignoring that for now. As far as where I want to put my output, I'm going to put my output right here, and it may write over the stuff that's there. That's okay. It might tell me that it's going to write over it. Yeah, it's going to overwrite existing data. That's okay. Oh, maybe it's not. Oops. Let me stop for a second. Let me just get rid of this. So I'm going to select all the stuff that was in the video from class. I don't really need it right now. That was just a simple regression. Right now we're doing multiple regression. I'm going to clear all here. Okay. So full model. I think we have space now. Let me go in here, data analysis, regression, everything's selected, looks good, levels, output, yep, all good. All right, let's do it now. I don't think it will. Oh, it did. Look at that. All right, well, that's okay. All right, so here we go. The coefficients. This is the part of this that we are focusing on right now. Okay, so this is the only part that matters to us at the moment for our model. All right, so we're going to perform the initial full model regression analysis. We write the sample regression equation in Excel. So if we're going to write it, let me just go ahead and say price. So let's just go ahead and label it sample regression equation. And let's left align that. I don't know why I did that. Okay. And here I'm going to say price is equal to, so 21,000, you can put dollar signs, 21,618.76. And there's a way to use the concat function to do all this, but you don't have to get that fancy. So it's going to equal minus 1,000 and $21.82 for every year. So age times age, and minus 0.03, rounding to the penny, times mileage. So every mile. Okay. So now we're going to, so we did that. Then we're going to write the interpretation of each coefficient in the model. So coefficients. All right. So I'm just going to copy this down. And these right here, I'm going to convert. In this particular example, this is money. Not really. I shouldn't do that. Let me take that off. Let me just go to number. Okay. And I'm going to say that this, and so let's go with the units. So the units are always going to be given, and I don't need this highlighted right now. Sorry. Okay. So the units are always going to be given as y over x. So it's y divided by x. Right? Rise over run. So because it's a slope, remember this is a slope. The coefficients are the slope. So this is going to be given here as price. So, sorry, dollars. Dollars over years. And this one is going to be given as dollars over miles. Right? Center that. Okay, so there are units. All right, so the interpretation. So here I would say that it is that the price drops by $1,021.82 for every year the car ages. Okay. The next one, it would be, again, and the drops becomes because it's a negative slope. If it was a positive slope, I would say the price increases, right? So you refer to the response variable. So I start by writing the response variable. Then I refer to the sign of the slope. So this one's negative, drops by, and then I write the coefficient, I write the slope. So this will be 3 cents. And then I say for every, and this is where I refer to the 1 unit increase in the predictor, for every mile the car is driven. Okay, so there's my interpretation, you know, if you want to have that. Okay. Finally, use the regression equation to make a prediction of the response variable for the values of the predictors given and interpret in a sentence. So I don't have this one set up, but let's just pretend. So predict the selling price of a, I don't know, 7-year-old car with, what do you guys think? Mileage, my range of mileage. I got to stay. Remember, we can't go outside the range of mileage. Let's say, I don't know, 72,000 miles on the car. So my predicted variable, my price is, and let's just be really clear because you guys are still learning this stuff. Predicted price. All right. So the predicted price is just going to equal. So maybe if you want to set this up, you can set up the regression coefficients and then the predictors, predictor variables. And I'll show you later how to do this. There's a way to do this a little bit more fancy, but we'll get there. I just, first of all, want you to do it by hand. So the regression coefficients, right? We're going to just grab these right here. Maybe we should grab what they are. And this is predictor variable values. Okay. So again, we don't really need all this highlighted anymore. Okay, so we got the intercept. And the predictor values. So we're always going to have the y-intercept. And there is a way of modeling without the y-intercept, but that is a more advanced. I don't know. It's really more advanced. We're just going to start with the basics. Okay, starting with the basics, we're always going to have the y-intercept, and then we're going to put in the value for age. So age is going to be 7 years old, and the mileage is 72,000. And we need to put that in as 72,000. Let's just confirm that in the mileage data, the raw data, we have to match the units. So yes, it is in actual individual miles captured. Okay, so we have that. So I should maybe move this predicted price down to here. This little table. Okay, and the predicted price then is going to equal. So there's this, okay, so I'm gonna do it 2 ways. So it's gonna equal the intercept plus the slope on age times the amount of age, right? Plus the slope on mileage times the number of miles. All right, so we get this. It's going to be the predicted price. And this one we do want to put in dollars because now we have canceled out the age in years and we canceled out the mileage on the slope. So everything is now given it to us as the predicted price is $12,309.21. Okay, I want to show you another function that works for doing this. It's the sum product. So what we just did happens a lot. So we're going to say sum product. So we just multiply everything here, row by row with everything here, and it's going to give us that same response. So that is another way to do that. Same calculation to get the predicted price. Okay, and then we are told the last thing we want to do is interpret as a sentence. Okay. So we could say the expected price of a car that is 7 years old and has 72,000 miles is 12,309 and 21 cents. Right, so there you go. If you go buy a used car over the Thanksgiving break, you now have an expected price. You have a model. This is real data. It's not that much data. And we will talk later about how much to trust it. But anyway, it'd be kind of fun to see how this matches up with like a Kelley Blue Book. And of course, this is not telling us the make and model, which is huge variability, right? So this is some of the stuff that's not when we were talking about random error and things that are not included in the model. Right? Make and model isn't in here. Where you live isn't in here. You know, history of car accidents isn't in here. So for the car. Okay. Anyway, I hope that helps you know how to answer how to do this assignment with the data that I assigned. Okay. That's it. Bye.